In the planning application, we can look at a business process which has been encoded using the Planning Domain Definition Language, or PDDL. So in this example, we look at a business process which is concerned with the evaluation and manipulation of electronic patient records for inclusion in a medical trial. Now, when the process is encoded as a PDDL, we end up with two files. One is a domain file, and the other is a so-called problem file. The domain file lists the actions which are available to us, as well as the parameters which each action takes, the preconditions of each action, and the observation, or that is to say the effects of each action on the variables at play in the system. You can see we have quite a number of actions in this case. The PDDL problem file describes the initial state of the system as well as the observed goal of the business process. Once we have these two files loaded, we can run a planner, like so, and that immediately generates a workflow for us, showing the various actions which we've defined, the sequencing of them, and this workflow is arrived at precisely because of the planning problem which you have described on the left-hand side here. So to look at a piece of it in detail, if we look at the anonymized patient record step, for example, and the request approval steps, here you will see that the request approval step is preceded by the anonymized step. And the reason for that is in the code, so that we see that the request approval action requires that the record has been anonymized. So let's see what happens when we remove that condition, which we could do like this. We're just removing that clause from the definition of the action. And now if we run the planner again, here we will find that the ordering of the actions has changed. We now have that the anonymized patient record follows the request approval action. In this way, we can change the PDDL code on the left-hand side and arrive at new workflows. We can test new workflows, and we can guarantee that each workflow is valid. That is to say that it will reach the desired goal without problems such as infinite loops.